Chemical compound. Before talking about the chemical compounds, we have to know that the atoms just lose or gains number of electrons to make its outermost energy level saturated with electrons. Those numbers call in valency. So, what the meaning of valency? Valency, it's the number of electrons that the atoms gains or lose or even shares during the chemical reaction. Okay, but we said before that the atoms may be metal, non-metals, or even noble gas. What about the valency of metals? The valency of metals, like this table, may be monovalent, maybe divalent, maybe trivalent. So here, the monovalent, like lithium, potassium, sodium, silver, and copper, while divalent, like calcium, magnesium, iron, lead, copper, mercury, while trivalent, like aluminum, gold, and again iron. So from this table, we know that some metals have different valency, like copper, maybe it's monovalent and calling cuprous, or divalent and calling copric, while the valency of iron may be divalent and it's calling ferrous, or trivalent and calling ferric. Okay, what about the valency of non-metals? The valency of non-metals, like also this table, maybe it's monovalent and maybe it's divalent. Monovalent, like hydrogen, chlorine, fluorine, bromine, and iodine. And maybe it's divalent in sulfur and oxygen. Okay, but here, the valency of non-metals, sometimes it's different. Some non-metals have more than one valency, like metals, of course. So, like what? Here, nitrogen and phosphorus. Nitrogen and phosphorus, maybe it's trivalent and pentavalent. And also here, the sulfur, maybe it's divalent, tetravalent, and hexavalent. What about the valency of noble gas? The valency of noble gas is 0. Why? Why? Because the outermost energy level is saturated with electrons, of course. So it doesn't need, or the noble gases don't need to share or participate in chemical reactions. So the answer gonna be because their outer electron shell or outermost energy level is saturated or completely filled with electrons. Okay, but there is another expression which is called an atomic group. Okay, what the meaning of atomic group? It's a set of different atoms, elements, joined together and behave like one atom during the chemical reaction and having its own valency and cannot be existed solely. So here, examples of the atomic group. So the atomic group behave like one ion. Okay, the examples of atomic group, like this table. Okay, and you have to know it. Hydroxide. Hydroxide is monovalent. Bicarbonate, nitrate, nitrite, and ammonium. So all of these examples are monovalent. And I said before that these atomic group or these atomic groups, okay, behave like one atom or one ion. Okay, here maybe the atomic group carbonate or sulfate, and carbonate and sulfate are divalent, while phosphate like trivalent. Okay. Okay, to write down the elements, or to write down the compound or the chemical compound, we have to write it down like chemical formula. What the meaning of chemical formula? First, we have to know the chemical formula of water. The chemical formula of water is H2O, while the chemical formula of sodium chloride is NaCl. Okay, the chemical formula of sodium chloride is NaCl, and the chemical formula of water is H2O. Okay, so here in sodium chloride, or the table salt NaCl, it composed of sodium and chlorine, one sodium atom and one chlorine atom, while in water H2O, it's composed of two hydrogen atoms and one oxygen atoms. Okay, so the chemical formula, it's a formula that represents the number and the types of the atoms in a molecule. So again, the chemical formula, it's a formula that represents the number and the types of the atoms in a molecule. Okay, so how can we write the chemical formula of a compound? Here we have steps. For example, I just wanna to write down the chemical formula of calcium oxide. Okay, the steps. Write the name of the compound in the word calcium oxide. Okay, number 2, write the symbol of each element or the atomic group down to the name. So calcium gonna be Ca, oxide, it's O. Number 3, write the valency down to each symbol. The valency of calcium is divalent, so it's gonna be 2. While the valency of oxygen gonna be 2 also. Okay. Number 4, and the last step, exchange their valencies and simplify them. Okay. So 2 gonna be gone to O, and this 2 gonna be gone to calcium. So it's gonna be Ca2O2, but I said that you have to simplify it. 2 over 2. So Ca1O1, and you don't need to just write down number 1. So it's gonna be CaO. So calcium oxide, it's gonna be the chemical formula of calcium oxide gonna be CaO. Okay, another example, aluminum sulfate, but this example gonna be by atomic group, which is sulfate. Okay, aluminum, write down the compound in a word aluminum sulfate, and write down the symbol of element. Okay, so aluminum, it's gonna be Al, and sulfate, it's gonna be SO4. The valency of aluminum, 3. The valency of sulfate is 2. You're gonna exchange the numbers. So 3, okay, 3 gonna be here, and 2 gonna be here. So the simple or the chemical formula of aluminum sulfate, it's Al2SO4 3. Okay, but you know how to write down the chemical formula of a compound, but what the types of compound? The types of compound may be acids, bases, oxides, and salts. Okay, acids. First, acids. What the meaning of acids and what the property of acids? Okay, they are compounds which dissociate or dissolve in water, producing positive hydrogen ions. Okay, while bases, what the meaning of bases? Bases, they are the compound which dissociate or dissolve in water, producing negative hydrogen ions. I'm sorry, hydroxide ions. Okay. Examples of acids: hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3. While the examples of bases: sodium hydroxide, NaOH, potassium hydroxide, KOH, calcium dioxide, CaOH2. Here, when you just say here the hydrochloric acid, okay, and sodium hydroxide, the acids just begin with H, positive ion, or hydrogen positive ion, while base ended with hydroxide ions. Okay. The chemical formula of all acids begins with hydrogen joined with one of negative atomic group except OH or hydroxide group. Why? Because if the hydrogen just be with OH, it's gonna be water, and water, it's not acid and it's not base. Okay, and they have a sour taste, while base chemical formula of all alkalis ends with hydroxide group. Okay, so acids, again, they have a sour taste, while the base have a bitter taste or feels slippery. The acids, they change the color of litmus paper to be red due to the presence of hydrogen ion, like this. While base, they change the color of litmus paper to be blue due to the presence of hydroxide ion. Okay. Oxides. Oxides, they are compounds resulted from the combination between oxygen and an element, even it's metal or non-metal. So here we have two different types of oxide: metal oxide or non-metal oxides. Metal oxides, they are formed from the combination of oxygen with metals, while the non-metal oxides, they are formed from the combination of oxygen with non-metal. The examples of metal oxides like sodium oxide, calcium oxide, and aluminum oxide, while the examples of non-metal oxide, carbon dioxide and sulfur dioxide. Salts, and that's the last type of compounds. Salts are exist in earth crust or dissolved into water. They have different property, maybe, or such as taste, color, smell, solubility in water, and others. Salts are produced from combination of positive ion with negative ion, like sodium chloride, the table salt of course, lead bromide, Okay, while maybe the salt formed or produced from combination of positive ion and negative atomic group, like sodium nitrate and magnesium carbonate. Okay, maybe also the salts are produced from the combination between positive atomic group with negative ion, like aluminum chloride or aluminum bromide. Okay, and the last type, salts are produced from combination between positive atomic group and negative atomic group. So here, maybe positive and negative ion, maybe positive and not positive ion and atomic group, maybe by combination of positive atomic group with negative ion, and the last thing, positive atomic group with negative atomic group, like aluminum or ammonium carbonate. Ammonium carbonate. Some mineral salts are classified into salts that dissolve into water, like sodium chloride, of course, potassium sulfate, calcium nitrate, and sodium sulfide. And the mineral salt maybe don't dissolve into water, or I said insoluble in water, like silver, silver chloride, lead iodide, lead sulfate. Thank you.